So on number 4, we're supposed to graph this cubic function. So the first thing I'm going to do is determine my transformations. And okay, the first thing I need to do is separate the horizontal stretch or compression from the horizontal shift. So I'm going to factor out a negative 1/3 from the interior. So to factor out a negative 1/3 is to like divide by negative 1/3. So negative 1/3 x plus 1 divided by a negative 1/3. So I'll divide each term by negative 1/3. This is just a 1, but then 1 divided by negative 1/3 is the same thing as multiplying by negative 3 over 1. And so this is minus 3. Okay? So when I graph my original function, it is a cubic function shifted to the right 3, flipped over the y-axis with a horizontal stretch by a factor of 3, opposite on the interior, and up 2. Okay? So I'm going to go right 3 and up 2, right 3 and up 2, and that is my center point for my cubic function. So in general, cubic functions look like this, but because of the reflection over the y-axis, it's now going to look like that. Okay? So when I draw my pattern for a cubic, I'm going to go, remember, x cubed. So 1 cubed is 1, 2 cubed is 8. 1 cubed is 1, 2 cubed is 8. And then 3 cubed is 27. And the reason why I'm going right and down is because of my flip. Okay? So the horizontal stretch by a factor of 3 means I'm going to go, I'm going to multiply the horizontal components by 3. So this is going to be over 3, and this is going to be over 6, and this is going to be left 3 and left 6. So my starting point, my center point, right 3, up 2. I'm going to go to the right 3 and down 1. So 1, 2, 3, and down 1. And then I'm going to go to the right 6 and down 8. So right 6 from 3 is 9, and down 8 from 2 is negative 6. And then I'm going to go left 3 and up 1. So left 3 and up 1. And then I'm going to go left 6 and up 8. So I'm at 3, so negative 3, and up 8 from 2 is 10. Okay, and then I'm going to connect. And then I'm going to connect over here. Ah! Close enough. Okay, and that is my original function. And then I need to find the inverse. So for the inverse, I'm going to switch x and y. So I've got x equals negative 1/3 y plus 1 quantity cubed plus 2. I'm going to subtract the 2. I'm going to take the cubed root. So the cubed root of x minus 2 equals negative 1/3 y plus 1. And then I'm going to subtract the 1. So negative 1/3 y. And then the opposite of multiplying by negative 1/3 is to multiply by negative 3. So if I multiply the entire side by negative 3, then I get negative 3 times the cubed root of x minus 2, and then negative 3 times negative 1 is plus 3. And so my inverse, f inverse of x, equals negative 3 times the cubed root of x minus 2 plus 3. So, as far as transformations go, we're going to go to the right 2, up 3, flip over the x, and then we've got a vertical stretch by a factor of 3. So again, if this has a horizontal stretch by a factor of 3, then this is going to have a vertical stretch by a factor of 3. It should always stay the same. If it's a stretch, it's a stretch. Okay. So first I'm going to go to the starting point, or the center point. I'm going to go the right 2 and up 3. The right 2 and up, just kidding. Okay. So go the right 2 and up 3. The next thing I'm going to do is think about my shape. So normally a cube root function looks like this, but because of the negative, because of the flip, it's now flipping over the y. This is going to go up here, and this is going to go up here. So my pattern is going to be to the right and down, to the right and down, to the right 1, down 1, to the right 8, and down 2. So these switch because the cube root of 1 is 1, and the cube root of 8 is 2. So the cube root of 1 is 1, and the cube root of 8 is 2. but it's a vertical stretch by a factor of 2 or 3. So this is going to be 3, and this is going to be 6. This is going to be 3, and this is going to be 6. So from my starting point, I'm going to go to the right 1 and down 3. To the right 1 and down 1, 2, 3. Okay. Now I'm going to go to the right 8 and down 6. So I'm going to go to the right 8 from my center point. 1, so I'm at 2, so that's 10. And then down 6, I'm at 3, so negative 3. So I know the left-hand side of my, or I guess the bottom half, right-hand side of my cube root function looks like this. And then I'm going to go to the left 1 and up 3. So left 1 up 3. And then I'm going to go to the left 8 and up 6. So from my center point, I'm going to go to left 8, which puts me at negative 6. And then up 6, which puts me at positive 9. And so then we have this shape right there. So just to make them super clear, those are the coordinate points that I would expect. And that is definitely a reflection across the diagonal. So if I were to draw all the diagonal, you would see that they are a reflection across it. Okay? You can also tell that the coordinate points flip. This is a point 3, 0, this is a point 0, 3, this is a point 3, 2, this is the point 2, 3, this is the point 6, 1, this is the point 1, 6. Yeah? Okay. So there is number 4. Number 5 starts with the quadratics, and with quadratics you have issues. So that's why we have domain restrictions. So number 5 has, well, first off, directions. Graph the following functions and their inverses on the curve provided. State the transformations for each function. State the domain and range of each. Okay, so this is a quadratic function shifted up 4, flipped over the x, and with a vertical compression by a factor of 1/3. So when I think about a quadratic, normally a quadratic looks like this, but because of the flip, it's going to look like this. Okay, so I know I should have a quadratic opening down. Up 4, so I'm going to go ahead and up 4 and plot my starting point. And then, so normally my parabola would go 1 squared is 1, 2 squared is 4, 3 squared is 9. And I would do the left-hand side as well. But it says only for x is greater than or equal to 0, which means I'm only going to graph to the right of 0. So, I might even be able to see the next one, so I'm going to go ahead and give myself a little more space. If I take my center point and I go right 1 down 1, right 2 down 4, right 3 down 9, and right 4 down 16, then I have a vertical compression by a factor of 1/3. So this is now a third, or 0.3 repeating. This is now 4/3, or 1.3 repeating. This is now 3, and this is now 16/3. 3 goes in 16 5 times with 1 left over, so 5.3. So from my starting point, I'm going to go to the right 1 and down 1/3. I'm going to go to the right 2 and down 1.3. I'm going to go to the right 3 and go down 3. 1, 2, 3. I'm going to go to the right 4 and go down 5.3. So 1, 2, 3, 4, 5.3. And I could probably see another one, 5 and 25. 25 divided by 3 is 8. Yeah, I could see another one, but I'm just going to go ahead and graph this and call it good. So if I graph that, I'm going to draw an arrow because if I'm not going to keep plotting points, then I don't need to pretend like I know where it's going. Okay. And then I want to find the inverse. So if x equals negative 1/3 y squared plus 4, then the first thing I'm going to do is subtract the 4. I'm going to multiply by a negative 3. Yes.
I need to be like a scripter for a minute.
Okay.
Thank you.
So those simplify out, and I'm left with negative 3x plus 12, although if we leave it as negative 3 times x minus 4, it's easier to see the transformation, so I'm going to go ahead and write both. And then we take the square root. So that equals y squared. And then when you take a square root, you actually get 2 answers. So it's either the plus or the minus of this, right? So here's the thing. If I had started with an entire parabola as my original function, then the inverse would have been both of these square roots. But since I only started with the right-hand side, it can only be one of those square roots. So when you think about it, okay. As far as transformations go, this means go to the right 4. And this means flip over the y-axis, the negative on the interior. So when you think about a quadratic or a square root, usually it looks like this, but when you flip it over the y-axis, it looks like that. So the direction that we should be going is to the left, okay? And then the 3 on the interior is a horizontal compression by a factor of 1/3. Again, if the original one has a vertical compression by a factor of 1/3, then this one has a horizontal compression by a factor of 1/3. Okay? Okay. I'm going to go to the right 3 and plot my initial point. If you think about going to the right 3 and graphing the positive square root and the negative square root, only one of those is able to be the reflection across the diagonal of the function that did this, right? So when you think about which one is the reflection, it looks to me like it's going to have to be the positive side. And in fact, if you just go ahead and think positive and right, the right-hand side means the inverse is the positive square root. But we can also see that by finding the domain and the range. So right quick, I'm going to go back to my original function and find the domain and range. So for f, the domain is from 0 to infinity. Left to right, it goes from 0 to infinity, and that is determined by that. My range is low to high. The lowest it goes is negative infinity, and the highest it goes is 4. Okay? Well, that means no matter what my inverse is, I already know its domain and range. I know that the domain is negative infinity to 4, and I know that the range is 0 to infinity. So the range tells me whether or not I'm the positive square root or the negative square root. I'm 0 and up, which means I have to be the positive square root. Okay? So, here we go. The square root function has a pattern. Normally I would say square root is over 1, up 1, the square root of 4 is 2. The square root of 9 is 3, but we're going to the left. So over 1 up 1, over 4 up 2, and over 3 up, over 9 up 3. But I have a horizontal compression by a factor of 1/3, which means instead of 1, it's over 0.3, instead of 4, it's over 1.3, and instead of 9, it's 3, and over 16, instead of 16, it's 5. So we're going to use that. So I'm going to go from the starting point, which was just to the right 4. Oh, I forgot. And over the y. So as far as my transformations go, those are those 3. Okay, we're going to go to the right 0.3 and up 1. So to the right 0.3 and up 1. I'm going to go to the right 1.3 and I'm going to go up 2. I'm going to go to the right 3 and up 3. So 1, 2, 3, up 1, 2, 3. And did I go to the right 4? I didn't go to the right 4. Okay, so right 4, and then I'm going to go to the left 0.3 and up 1. To the left 1.3 and up 2. To the left 3 and up 3. And I'm going to go to the left 5.3 because of using this right here. I'm going to go to the left 5.3, so 1, 2, 3, 4, 5.3, and up 4. So 1, 2, 3, 4. Okay, so I'm going to connect those. I'm just going to draw an arrow because I don't know where the next point is, although I can find it. And so they're kind of right on top of each other, so let's just make sure. Is my domain negative infinity to 4? So negative infinity up to 4. Good. And my range is from 0 to infinity. Good. Okay. So as far as my answers go, I've got state the transformation, so up 4, flip over the x and vertical compression. Domain and range, domain and range. right 4 horizontal compression by negative 1/3 and flip over the y. And my inverse, I gotta make sure I indicate my inverse is the positive square root. So I'm gonna say f inverse of x equals the square root of -3. I'm gonna go ahead and write that one, -3x plus 12. And that is now smudgy. -3x plus 12. Okay? And remember, you should always be able to check and draw the diagonal, and if it is a reflection across the diagonal, then it is promising that you drew the right inverse in function. Okay? Alright. Number 6. Number 6 is a quadratic as well, and it's also restricted. So it is the to the left of -4 and equal to -4. So as far as transformations go, let's first list those. The 2 is a vertical stretch by a factor of 2. Okay. The +4 in the interior means go left 4, and the down 4 means go, or the -4 means go down 4. And those are my 3 transformations. So I'm going to go right 4, down 4. 1, 2, 3, 4, down 1, 2, 3, 4. And I'm going to graph the left-hand side of my parabola and with a vertical stretch by factor 2. So normally parabolas again, we go over one to the right and up, and to the left and up. So we're just going to draw to the left and up. So over 1 up 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. But we have a vertical stretch by a factor of 2. So we're going to go the right 1 up 2 to the right 2 up 8, and there's no way I'm going to be able to see 18. So from my starting point, drawing the left-hand side, only to the left of -4, I'm going to go left 1 and up 2. And I'm going to go left 2 and up 8. So I'm at -4, so it puts me at +4. So this is an elongated parabola. And this is going to say stretched. Okay, and now I need to graph the inverse, or find the inverse and then graph it. Let's go ahead and find the domain and range of that. Domain is left to right, and actually it already says it right there. Domain is -∞ to -4, -4 included. Range is low to high, so the lowest it goes is -4, and the highest it goes is up to infinity. Which means the domain and range of my inverse should be -4 to infinity, -∞ to -4. Okay, so x equals 2 quantity y plus 4 quantity squared minus 4. Solving for x, I'm going to add the 4 over. So if we add this 4, I've got x plus 4 equals 2 times y plus 4 quantity squared. Then I'm going to divide by 2. Dividing by 2, you could write it as 1/2 x plus 4. You could write 1/2 x plus 2. I'm going to go ahead and leave it like this so I can see my transformations. And leave it like that. So y plus 4 quantity squared. I'm going to take the square root. When you take the square root, there are 2 answers. We have to decide which one is which. And then I'm going to subtract the 4. So plus and minus the square root of 1/2 quantity x plus 4, and then minus 4 equals f inverse of x. Okay, so when I think about my quadratic, or my square root, sorry, I'm going to have a square root like this and a square root like this. But I know that my range for my inverse is -∞ to -4. -∞ to -4 means it's going to be the bottom half of my square root. So also remember, if it's the left-hand side of the parabola, it's the if it's the left-hand side of my parabola, then it's the negative square root. So my final answer is that f inverse is that negative square root of 1/2 times the quantity x plus 4. Alright, let's take the transformations. We're going to go to the left 4. it has a vertical, horizontal. It's on the interior, right? So it's a horizontal stretch by a factor of 2. And remember, if this one has a vertical stretch, then this one has a horizontal stretch, the inverse. They have the same stretch or compression, just direction changes. The negative on the interior is a flip over the x, and the 4 on the exterior means go down 4. So I'm going to go left 4 and down 4. Same starting point as before, but that makes sense because it lies on y equals x. So negative 4, positive 4. And then we're going in this direction because of that negative. Yeah? And so normally I would say over 1, down 1, and over 4, down 2, over 9, down 3. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Always remember just the function you're dealing with. Plug in the x and then there's your y. But we have a vertical stretch by a factor of, horizontal stretch by a factor of 2. So we're actually going to the right 2 and down 1, to the right 8 and down 2, and to the right 18, but we're not going to be able to see that, so it's just these 2. So from my starting point, I'm going to go to the right 2 and down 1, and I'm going to go to the right 8 and down 2. And so my inverse, oh, just kidding, couldn't see it, to the right 2 and down 1, according to this right here, to the right 2 and down 1, and then to the right 8 and down 2. So to the right 8 and down 2. And if I connect those, making my negative square root, then you can see how that it ends up looking like a single function, but it is just half of an upright parabola and half of a sideways parabola reflected across the y equals x. And there we go. And your coordinate points should be the exact opposite. This one, negative 4, same thing. Negative 2, negative 5, negative 5, negative 2. 4, negative 6, negative 6, 4. Okay? And so, there's my inverse, my domain and range, my transformations, and there we go. Now this flip over the x, I mean, it is a flip over the x of the original square root, but in actuality it's just knowing this is the left-hand side.